Hello, welcome back to our chapter 5.5 video lesson. We are solving equations with rational expressions in them. And hopefully this should be just a little added on to what we did in our earlier lessons of chapter 2, because we solved equations with fractions and we just multiplied through by the LCD, and that's what we're going to do here. So we're looking for our LCD between 5 and 2, which is 10. So we're going to multiply each term by 10. So 5 cancels out with 2. 2 goes into 10, 5. And so we have 2x equals 5x minus 90. And if we subtract 5x, we get a negative 3x equals a negative 90. And then if we divide by a negative 3, we get x equals a positive 30. You can't read that. X equals 30. And there are no exclusions because x is in the numerator, so there's nothing to worry about. Okay, example 2. Again, we're looking at a multiple of 3, 6, and 2 that is common, which would be 6. So I'm going to multiply each term by 6. 3 goes into 6 twice. The 6 is canceled there. 2 goes into 6 3 times. So I have 2y minus y plus 3y equals 6. And that gives me 4y equals 6. And if we divide by 4, we get 6/4 or 3/2. Okay, we're going to jazz things up a little bit because example 3, we're looking for the LCD, but we have expressions now. So our LCD has to include a factor of 5 and a factor of x plus 5. So I'm going to multiply each of these by 5 times x plus 5. And I'm going to show you a shortcut here in just a minute. So minus 5 times x plus 5 times x over x plus 5. Okay. So the x plus 5 cancels there, the 5 cancels there, and the x plus 5 cancels there. So we're left with 5 times 2 is 10 equals 2 times x plus 5 minus 5x. And now we can solve for x. So I have to distribute. So we'll have 10 equals 2x plus 10 minus 5x. Is 10 equals 2x minus 5x is a negative 3x plus 10. And I'm going to subtract 10 from both sides. And then we end up with 0 equals a negative 3x. And when we divide by a negative 3, x equals 0. And then we just check to make sure, can I put 0 in for x? And I can, because that will still leave me with the denominator that is 5, and that's good. Let's flip the page. Example 4. We are working on 2 expressions in the denominator, so we need an LCD. They're each going to be a factor of the LCD. And we can leave them factored because that's what you need, is the factors to cancel anyway. So leaving them factored actually simplifies things. And so I'm going to multiply a plus 1 times a plus 2, and then over here, a plus 1 times a plus 2. And now I want you to notice I've multiplied both terms of the equation by the LCD. And what happens then is the denominator cancels on the left and the denominator cancels on the right, which is what we want. And notice that the factor that wasn't included in the denominator is what's left. And the factor over here that wasn't included in the denominator is what's left. So really, we could shorten this by finding the LCD and looking for the factors that are not included in the denominator, and that's what you need to multiply by. It saves you a step of canceling out. So this simplifies to 5a plus 10 equals 4a plus 4. And subtracting 4a leaves us with a plus 10 equals 4. Subtracting 10, and then a is a negative 6. And a negative 6 is okay because we can have a negative in the denominator, that's okay. We just can't have 0. Okay. And we could also write it as restriction. So up here on example 4, we could have said that we can't have a plus 1 cannot equal 0. So that means if you solve a cannot equal negative 1, and a plus 2 cannot equal 0. So that means that a cannot equal a negative 2. So if you arrive at either of these as an answer, a solution, you know it cannot work. So let's do that for example 5. So example 5, the LCD must be an x plus 1, and then this 5 is really 5 times x plus 1. So the x plus 1's already been included, but we need a 5. So the only restrictions are x cannot equal 0 from here, and then x plus 1 cannot equal 0, so x cannot equal a negative 1. So I'm going to look to see, my first fraction is an x, so it's missing the 5 and the x plus 1. So that's all I have to multiply through by, and my denominator cancels. And then the second fraction, 1 over x plus 1, is missing just the 5 and the x, and that denominator cancels. And on the right-hand side, that denominator is just missing the x, and that denominator cancels. So now we have 5 times 2, so 10 times x plus 1 minus 5x equals a negative 2x. We're going to distribute our 10. Combining like terms, we have 5x plus 10 equals a negative 2x. And I'm going to subtract 5x to move my x's to the right. And then to solve for x, we're going to divide by a negative 7. So x equals a negative 10/7. And that is not on the list of restrictions up here, so it's safe to use. Example 6 says we have, let's see, y plus 2, y minus 3, and then whatever this factors into, which appears to just be a y minus 3 and a y plus 2. So we already have them. So LCD is y plus 2, y minus 3. So that means our restrictions our y is a negative, cannot be a -2, that will cause that to be 0, and y cannot equal 3 when y minus 3 is equal to 0. So those are only two restrictions. So I'm going to multiply through by the factors that each denominator is missing. So the first fraction is missing the y minus 3. And remember, then our denominators are gone. Subtracting, the second fraction is missing the y plus 2. So 2 times that equals, and the third fraction already has the correct denominator. So we have just the numerator. When it's already, when both, when all parts of the LCD are included, we don't have to multiply by anything. So we have y minus 3 using distributed, we have a -2y, -4 equals a -2y. So combining like terms, we have y minus 2y is a -y minus 7 equals a -2y. And if we add y to both sides, we have a -7 equals a -y. So the taking the opposite of both sides, y equals 7, and that is not a restriction, so it's good to use. Let's turn to the last page of notes. And again, we need to get our LCD to look for restrictions. So I'm going to factor these. So we have 5 times x plus 2, and then 4 times x plus 2. So 4 times 5 times x plus 2. Okay, so the first fraction, to cancel out the denominator, we only are missing the 4. So we have 4 times 2x minus 3 plus the second fraction is missing the 5 times 3x minus 2 equals, the 1 is missing all of it. So 4 times 5 times x plus 2. So let's simplify. We have to distribute a couple of things here. So 8x minus 12 plus 15x minus 10 equals 20x plus 40. Combining like terms, we have 23x minus 22 equals 20x plus 40. So I'm going to subtract 20x and then add 22. So we'll have 3x on the left equals 62 on the right. And when we divide by 3, we get the result for x. And that's a fraction. We'll leave it as a fraction. It does not divide evenly. So graphing rational functions, the main thing that I want to get home on a rational function is that there is a thing called an asymptote. An asymptote is when the y value gets really, really close to a number when you're hitting your extreme. So hitting the extreme when x gets really large or when x gets really small. So when x gets infinitely large to infinity, our denominator is going to get infinitely large. And so this overall fraction is going to go close to 0. So there is a horizontal asymptote called an HA, a horizontal asymptote at y equals 0. And we have a vertical asymptote when the denominator equals 0. So if you say x plus 3 equals 0, then x is a -3. So there is a vertical asymptote there. So as x gets really large, this goes to 0. And then when x gets to a -3, it's going to have an asymptote there. So I'm going to show you what this looks like in Desmos. I'm going to share my screen here. And we're just going to do the function y equals 1 over x plus 3. And you can see the asymptotes. So you can see where there's a horizontal asymptote at y equals 0, and then the vertical asymptote up and down here, x equals a -3. And likewise, the next one, if we graph it, y equals 4 divided by x minus 2, you'll see something similar happens here. We again have a horizontal asymptote at y equals 0, but we have a vertical asymptote when the denominator equals 0, which is at x equals 2. So I'm going to show you that here. Because x minus 2 equals 0, so x equals 2 is a vertical asymptote. So the function can't cross the x-axis. There's no x-intercepts. And it's got this vertical asymptote here. And then our last one is something similar. The vertical asymptote is going to be when x plus 4 equals 0. So at x is a -4. And there's going to be a horizontal asymptote at y equals 0 again, because as x gets infinitely large, the output goes to 0. So here is our vertical at x equals a -4. So catch me back for another video.